talk about something that's near and dear to our hearts, which is trust. Is edge AI something you can trust? What does trust mean when AI is on the edge?
Edge devices, there is this common misconception where because the data is processed locally, it's more protected. But practically, that's actually not the case.
If it says Microsoft on it, then I'm like, okay, I guess I'll trust Microsoft to do the right thing. But when I'm, pumping gas at the Chevron and I put my credit card in, I don't know, like who am I trusting?
When you look at the risks involved with using AI, my honest answer will be we don't know. We are still exploring that.
The homomorphic encryption, you are able to deploy it invisibly, so to speak. It doesn't change the data life cycle, but it protects the data and models inherently.
It took a while to sort of come up with the systems that end users, could really trust. People are now more educated about having sovereignty over their own data. How important is it that we trust the hardware itself?
Just to make sure I'm on the same page with Ro.
This is a debate, by the way. You don't have to be on the same page, so it's fine.
Can you also disagree to myself, since this is a debate, okay?
Welcome to the Edge of Tomorrow, the Edge AI Debate, a spin-off series of the IoT Podcast brought to you in collaboration with the Edge AI Foundation. We're bringing together some of the brightest minds in Edge AI and beyond for discussions on the most pressing challenges and opportunities shaping the future of AI at the edge. This isn't just another AI podcast. Every episode cuts to the core of the technology we're building and the path we're on, offering diverse perspectives and hard-hitting analysis, and the kind of conversations that leave you questioning everything you thought you knew about Edge AI. This episode is brought to you by the Edge AI Foundation, a global community of innovators, researchers, and industry leaders working to make Edge AI more accessible, sustainable, and impactful for the real world. At Edge AI Foundation, we believe the future of AI isn't just in the cloud, it's at the edge. We're focused on building and scaling intelligence where it matters most, in the devices, sensors, and systems powering our everyday lives. Now, let's dive into the show. All right. Welcome, everyone. Welcome, listeners. We're here for another episode of Edge of Tomorrow, the Edge AI Debate. And today, actually, we have some distinguished guests. We're going to talk about something that's near and dear to our hearts, which is trust. That is such a loaded term. We're going to talk about that word. But how does it apply to Edge AI? And really, basically, is Edge AI something you can trust? Can you trust Edge AI? Or how do you trust Edge AI? It's it can be interesting discussion because the more distributed nature of AI on the edge, lends itself to some interesting approaches. And so it's designed as a debate, but, I don't think we're going to debate trust per se. I think we're all on the same page there. But why don't we welcome our guests here, Rosario Cammarota, Chief Scientist for Intel Privacy Lab. You want to kind of introduce yourself?
Yes, Pete, thanks for having me. So I'm Ro. I lead an organization that pursue privacy technologies research with probably secure data protection and privacy, all the way from innovating in algorithms down to percolate these techniques in silicon, and by doing so, making privacy ubiquitous in the IT infrastructure.
Cool. And where are you calling in from?
Today, I'm calling from my hometown in Italy, but typically I'm based in Orange County, California.
Oh, interesting. Okay. Sounds good. And Aydin Aysu, founder of MithrilAI. Hopefully I pronounced that right.
Yeah. Thank you, Pete, for having me. So I'm an associate professor of computer engineering at North Carolina State University, where I lead a small team of PhD students and guide them through their laborious process of getting a PhD. And I also help solve some problems in the hardware security domain in this in my position. I also, as you mentioned, I also have a different hat. I am a co-founder of a startup that is looking into commercialization of these new technologies in the context of edge AI, security, and privacy.
Fantastic. I think I met you because I think you spoke at our Austin event. Edge AI Foundation had an event at in Austin, Texas, I think late February. I think you might have been one of the kickoff
Yeah.
And
We had 2 talks. One I did myself as a keynote, where I talk from my MithrilAI hat, and then we had a joint talk with my PhD student, where we talked about some research project. It was an amazing event. Thanks for
that was
organizing.
great. I think you talked about how to steal AI models, like a kind of a how-to guide. So that was interesting. So yeah, I should probably introduce myself. Pete Bernard. I'm the CEO of the Edge AI Foundation. I am dialing in from Bellevue, Washington, here in the Pacific Northwest. So I think we've got a pretty good kind of global coverage on this call. The Edge AI Foundation, world's largest community of developers, tech makers, and academia focused on Edge AI. So this is a great topic. It's something that, I would say on a weekly basis comes up about how do we think about trust and security in this space. Before we jump into it, I just for the users, listeners out there, when you say trusted system, when I look it up, trusted system, a computing system designed to maintain the integrity and confidentiality of data, ensuring it functions as intended and is resistant to tampering or unauthorized access. Pretty straightforward, but there's obviously a lot of complexity there. So why don't I kind of throw it out to both of you? What does trust mean when AI is on the edge? So, Ro, do you want to kick in on that? What does that mean for you?
Yeah, well, let's start with your definition. It was very technical, right?
Yes.
And when it comes to the edge that is very close to a user, I'm a user myself, even a picky one. I kind of say, I have blind faith in this device or something like that. I do have blind faith. If I do, then it means that I do trust the device. But then I want to draw a contrast between the way we use the information technology infrastructure typically, and what is the way that we use the infrastructure since a mobile and headless device came about, and what happens with artificial intelligence. So where does trust go? When we look into a cloud infrastructure, you do believe that there is an infrastructure where there are pretty high quality standard in terms of security, data privacy, data protection, and etc. And the brand of the owners of the infrastructure, whether it is Google, AWS, and things, is actually what gives you trust. I'm interacting with Google and I'm trusting it's doing a great job with my data. So Facebook or Meta, so AWS, and etc. Now, when we go, and in the case of artificial intelligence, there is the problem that you have all these automatic systems that have agency on our data. Okay, and at that point, digital data inherently, can be copied indefinitely and can be abused indefinitely without us knowing. And you would say, well, the problem is definitively different, but the big infrastructures that I use every day, I'm very familiar with them and things I will continue having trust. Now, if you move to the edge devices, there is this common misconception where because the data is processed locally, it's inherently close to me and therefore it's more protected. But practically, that's actually not the case. It's actually more blind faith than everything else. And going back to your definition, to put it a little bit in short, I think trust is really something about creating a verifiable assurance that the big brand kind of gives it to you, the brand that comes into your hand with the mobile device, unless it is Apple, Samsung, Qualcomm, doesn't give it to you, especially where the edge device is an IoT device. Okay, and it's not something else like this. Okay, it lacks that brand, so to speak. So it all comes in creating a verifiable assurance to a level of intuition that anyone really can understand.
Right. No, that makes sense. Aydin, what do you think about that? What does trust mean for you when you think about AI and the edge?
Well, in general, if you put AI and edge to the side, so the first thing I teach in my graduate course is information security practices and principles, where you have the CIA triad, right? Confidentiality, integrity, and availability. So what does it mean? What does this CIA mean for the edge AI systems? I can talk maybe a little bit about that. So confidentiality means whenever we do run a task at the edge, it should be kept secret from adversaries. Integrity means in this context that the computations itself are following a well-known recipe. We can discuss if that recipe itself is trusted or not, but we have a sequence of operations and that's run without any tampering in that sense. And availability means that the device is active and it's online. Now we can be even more technical and say that, we can also put non-repudiation into this, and which means that a device, when commits into certain action, you cannot take the commitment back, right? This actually, I can talk about an hour of what that means for AI, but at a high level, that means the device is not leaking information. And the second thing is if the device is working as it is supposed to be working without any extra operations, and that in general it's responsive to our actions.
Right.
So those three things are especially challenging for edge AI systems where adversaries can even get physical access to the devices.
Right. Yeah, I mean, some of what we're talking about here, and we're starting with this kind of what is trust is, when we think about embedded systems or distributed systems, right, there's inherently a different sort of trust approach than if I just throw my data into the cloud and, like you said, if it says Microsoft on it, then I'm like, okay, I guess I'll trust Microsoft to do the right thing. But when I'm, pumping gas at the Chevron and there's some gas pump there and I put my credit card in, I don't know. Like, who am I trusting? Chevron? I mean, what's going on there? So that's kind of the challenge, I think, with these more distributed systems, is that we have a lot of players involved, and who is standing up to trust that. Now, I could argue too, like, there's always a brand, or the entity that you're engaging with is inherently making a promise of trust, right? So if it's Chevron at the gas station or McDonald's kiosk, you're assuming McDonald's is not broadcasting your French fry order out to the internet. So someone's standing up and saying trust, but I guess the question is, kind of moving it back to the AI stuff. How does AI add new risk into this above and beyond sort of your standard distributed kind of OT systems, right? There's always OT system risk, but what does AI add to the mix in terms of risk and trust?
I can take a crack at it. So I think, I believe I mentioned it, but I think it's about AI having more agency on the data. But I think we do want to double click on that. A typical program has a completely deterministic behavior, and therefore, given the same query to this program or how the way the program is triggered with some input, it will give the same output. For an AI model, that is not true. And when you are using AI to make decisions, these decisions may change for the same input under different circumstances. And the way it does so, it carries a certain amount of non-determinisms. And there are surprises that come with that, because on the one end, it's about deciding. On the other end, it's really whether you know or not, or you have had the possibility to consciously opt into the use of AI, and then all of a sudden you find a number of customized recommendations or actions that comes at time that you don't believe it should be there, or the idea of having a system that is really customized to your behavior, and therefore it provides you as really an assist, right? And ahead of time gives you things timely, like an administrator would do for you, right, is very appealing. The way it actually happens with AI is that it doesn't have all that being considered that you are admin. Thus, it's just triggered by data and flows with it, and the output comes. So to me, I think this has a lot of potential, but it also has a lot of risks associated with it. Part with the data and part in the way it actually interacts with as an actuator in the life of the owner of the device that is next to you, thanks to Alexa or the various Google device, or even your phone with now this advanced Siri, for example, on Apple phone, like Siri Intelligence.
Right. So, I mean, there's the risk of kind of leakage of your, I don't want to say persona, but, if AI is kind of responding to your, yourself, then, the leakage of that data. So going back to my McDonald's example, and I would never do this, but if I opted into some sort of facial recognition every time I drove up to the drive-through, it knew I was Pete, and it said, hey, you want, you had that chicken thing last time. How about we do this? And it starts to sort of use AI to sort of, and that's more machine learning, but still, that kind of data, how do we keep that private? That kind of adds an extra risk. And then there's also the issue of models, right? So these models and the training data, the data sets and the models themselves are IP and valuable IP. And I know, Aydin, that was part of your talk in Austin was, how do we secure these models? This is like a new workload and a new set of IP now that's being introduced into this. And what are your thoughts about that?
Yeah. Well, in general, so when you look at the risks involved with using AI, my honest answer will be we don't know what risks are there. So we are still exploring that heavily in research as well as in the industry. So one specific issue that you mentioned, the technical risk, is with model theft. We put a lot of emphasis, data, and a lot of expertise into training these sophisticated models. And if we want to push them to the edge and say, like, maybe a smaller version of this should be running at the edge, then there is a significant risk of model stealing. And there are 1,000 different ways to do that. Each year we learn about new risks involved that are associated with it. But I think the more important, like if I go one level above, there is very little work in categorizing these risks. So for conventional stuff, non-AI, general systems, we have some CVE, CWE databases that lists a number of different issues. We need to put more emphasis into how to extend this for AI systems. And luckily, there is a new initiative that I'm aware of, which is called MithrilAI, that actually looks into how unique vulnerabilities exist and how they can be mitigated in the context of AI. And that, of course, includes edge AI.
And is that like kind of best practices, industry standards, or is it more of a database of knowledge? Or
it's both, but it's very new. It has only started a few months ago, and we have to see how it evolves over time.
Okay, interesting. I guess one of the questions too is, in this case, you mentioned the model theft and I've heard about data set integrity, or I would say, sort of the data set provenance. Let me say that. So I've heard that too, especially in some of like kind of the aerospace and, DoD, like folks are like, where you really need deterministic systems. They're like, well, where did the data set come from that this model is even trained on? How do we know the provenance of that data? So I think that's another question, unsolved. So to Aydin's point, lots of interesting open issues. I guess the other thing that, when we talk about edge AI and safety and security and trust, I mean, how important is it that we trust the hardware itself? Can we secure edge AI without trusting hardware? Is that
so? Again, this goes back to a more capable system versus more resource constrained system and decentralization that the edge brings into it. So there is plenty of security mechanisms and security architecture solutions based on system security approaches that are very consistently deployed, where systems are actually capable, for example, in the clouds and in data centers in general. When it goes to a less constrained device, the more you go to the edge, what happens is that the device of course, it would be desirable to have a root of trust, a trusted execution environment, all kinds of side channel protections that Aydin was talking about, and has been pioneering how you do that for avoiding stealing machine learning models. Right, but the reality is that you do have resource constraints that actually prevents and also time to market and resources to realize a product that might go to the market, but actually prevents basically to have a fully qualified system. So where in the cloud you can have something that is very high quality system security protected, at the edge, that's something that dilutes the more you go toward the edge down to dust sensors, form factors. Okay, so then the idea is that are there mechanisms where you can inherently protect the data, whether your infrastructure or portion of the infrastructure is secured or is consistently, basically, it's not fragmented with devices that have different levels of security, and actually the combination of those may create holes even if the device and the communication channel are actually secured, because there is discrepancy in the level of security that they provide. And so in terms of techniques, we have the cryptographic techniques that wherever you can use them, you should. And in this case, you have a cryptographic method to process encrypted data that envelop the data and make them secure pretty much regardless on whatever is the trust in the system underneath. Of course, they cannot be deployed alone, and the system security architecture becomes lighter but more sophisticated conceptually, which throws off a lot of people, by the way. And among these techniques, there is homomorphic encryption that is king, because when it comes to AI, wherever it's placed, it's a data life cycle problem, right? You talked about provenance, that's where the data is coming. Okay, but generally speaking, data life cycle and homomorphic encryption, if you deploy it and you are able to deploy it invisibly, so to speak, it doesn't change the data life cycle, but it protects the data and models inherently.
Right. And so, go ahead, Ian. Run in there.
Just to make sure I'm on the same page with Ro. So yeah,
for those who may not, by the way, you don't have to be on the same page, so that's fine.
Cool. So just for those who may not know what fully homomorphic encryption is, it's a technique that allows processing data without knowing the data.
Right.
So you can do actual meaningful computations on an encrypted data, which enables all great privacy and security purposes. But to go back to your question, so can we use fully homomorphic encryption or any kind of encryption without trusting the hardware, or is it a way to let go of hardware trust in a sense?
Right.
Or is it more like a supplemental tool that can help you achieve trust in this context?
Right. Well, I think that in a world of heterogeneous endpoint devices, as Ro mentioned, that have various levels of compute, and frankly, you know how it works. People don't always implement best practices on trust and security on endpoint devices. So if I am a Chevron or a McDonald's, is there a technique or something I can use to sort of, regardless of the trust, regardless of the hardware, I can still maintain a level of trust and security? Maybe not the best, but at least it hits the basic bar. I don't know. That's the question.
I think the problem is bigger than what you mentioned. So if we are talking about AI devices and edge AI devices, what does it mean to trust the hardware?
Right.
Right. So for example, let me give you an example. We can trust credit cards. Right? Credit cards do a lot of cryptography, a lot of high-value transactions. We trust them. We don't trust the manufacturers of the credit cards, by the way. We trust the system that certifies credit cards to be secure to a certain level. Right? There are all these labs, international labs in US and Europe and other places where you can send your chips and then they will get tested. They test it day and night. And at the end of the day, they can say, okay, this certifies this specific criteria, so therefore we can actually put a stamp on it and say you can trust the stamp, right? That means you don't trust the specific company that actually manufactures the chip, but you trust the whole testing infrastructure.
Sure.
We don't have anything like that for AI devices.
No, we don't have anything like that for AI. I mean, period. There's no certified trust. There's no security certification process right now for AI systems, as far as I know. I mean, is that really the answer, though? At the end of the day, getting back to the initial question about who are you putting your trust in? Do we need to have more of a system that says, oh, this has this stamp on it that says, I am trusted?
Yeah, I mean, Aydin mentioned about this new organization that's trying to standardize AI. I have been involved with the ISO-IC Joint Committee 1, Subcommittee 42 that looks in security for AI, and at various levels. But really, while it's the holistic approach, secures AI everywhere, it really targets data centers at the end.
Yes.
And there isn't really anything that goes down to the edge device. And I think the main problem there is really the fragmentation of the device that might hinder multiple vendors to go through a compliance process and have the stamp, AI secure certified or something like that. By the way, in many domains, including the credit cards, which was an excellent example that Aydin brought, and I actually wanted to follow up with the Chevron example that you say. You actually have one edge of that system, which is exactly the credit card. It's very well secured and certified. But the point is that the when it comes to AI, the field is nascent. Okay, and we're NIST categorized in one of their most recent documents threats and mitigations to AI system, and that's a very holistic approach. ISO-IC is trying basically to have countries agree on what are the risks and the mitigations and how would you actually go to define a certification process. It's not there yet, not because we are late or thing, it's just the course of development of this it's not that it's not on the radar, but it's not that does not prevent systems to go in the hand of users or in infrastructures today, and therefore the debate that we are having.
Right. And also the I mean, security and trust in a system is usually a layered approach, right? There's sort of layer on a few things, and it's like the piles of Swiss cheese, right? There may be holes in each layer, but when you stack them all up, you kind of lock it down. So things like encrypting models, things like using, trust zone. And so there is a best practice out there to sort of implement a bunch of these things. And then hopefully there's just enough security to block it. Yeah. What do you think about this notion of, running AI on the edge, and sort of data sovereignty? So the idea that, we're, having control over the model, having control over the data set that trains the model, you deploy the model locally, you're running it, how does that affect trust in the system?
That's actually, it's a question that has a lot of branches. I think let me try to cut it a little bit, right? And, let's start from the edge, so to speak. And, when we are close to the system and we generate data that we want to be processed because, I don't know, we want to overlap our favorite vacation picture with some artwork that we really like and things like that. And we start from our phone and we use a system in the cloud to do that. So clearly the picture is ours. And maybe even the piece of artwork, if we kind of purchase it, is probably ours, not because original is ours, but we have a license of use it, right? But at that point where you do the processing in the cloud to, try to find similarity between other pictures and do the best combined artwork that you want to do, the output of that is still mine because I'm actually accessing the system. And therefore, you would expect that the service that is doing all this processing somehow would not put the data even while processing unencrypted, or it would not do it in a form that other systems can actually copy the digital data or abuse it. And from this perspective, there are great examples like the latest application of homomorphic encryption that Apple did with Apple Caller ID, and with the similarity between pictures that really shows you how to layer to have a layer of software that is agnostic basically of the hardware underneath, and it's able to provide the functionality without seeing the data, right? And even if the computation is outsourced to the cloud, that you would trust to a certain degree, but not so much beyond the brand. Now users are more aware than before, so see the level of trust degrades a little bit. The use of cryptographic techniques to process encrypted data, whether you don't trust the infrastructure, the brand, or things like that, as long as the cryptography is implemented correctly, especially on the client side, which is close to you, then you have a privacy-preserving system, privacy-preserving AI, privacy-preserving AI at the edge. Does the fragmentation of this system matters? In principle, not, even though whatever happens to the hardware might make the whole cryptography to fail and produce garbage. Okay? So that's a different level of concern, but to some extent, now you have all the holistic protection that you need to the data, and you're getting your service.
Right. I mean, well, Aydin, go ahead. You look like you're going to say something.
No, so I agree with Ro in some sense here. So if you are going to protect or trust the data that's coming out of AI, or to validate its authenticity, then I think the answer is crypto, because cryptography is the only tool that we know on how to establish trust in the digital world. In the physical world, and like Ro mentioned, like when you buy a new piece of art, you get a certificate with it that says an expert actually viewed this physically, and
true.
you can sign it, right? So but in the physical world, we have the truth, right? So it's all analog. When we move from truth to trust, then we have to use crypto in the digital world. But specifics are very, it's not my area of expertise, so I won't comment on more on the specifics of this.
I think, go ahead, Ro.
But let me also disagree to myself, since this is a debate, okay? Let me challenge myself as well, because you talk about sovereignty, right? The deployment of IT technology today is very different from what it was before. So, and one example is the domain name system. So when the internet was invented and the domain name system, people were buying the domain, and these domains were completely independent from the infrastructure that was running them.
Right.
Then when large corporations for internet comes together, I'm not sure that my data on Gmail is really mine today. Why? Because the infrastructure is not free anymore. It's all run by a corporation. And now I think something that looks into data sovereignty and actually overlap a lot with the decentralization of AI, edge systems and AI running on edge system. I think the solution again when intercept crypto and the democratization of the IT infrastructure and giving back ownership, data agency to owner is what is happening with cryptographic ledgers. And let me tell you that cryptographic ledgers have also the advantage not only to be transparent, they can also be made confidential for certain type of data. And now you have the convergence of cryptography that, like Aydin was talking about, gives you a number of property that secures the processes around the data, right? And the auditing of the data. Again, now you have real assurance that is verifiable by you. Well, someone is telling you what it is, as well as you can add a layer of encrypted data processing on top of it to add confidentiality. And I'm a strong believer that in the future, the democratization of the information technology infrastructure with things like Ledger, Web3, and things like that will completely tilt the balance. and will provide a layer of security and trust across heterogeneous and decentralized devices.
Right. Yeah. And I think as people get educated, I would say, I tell people we're still in sort of the steam engine era of AI, right? It's, it basically works, but you have to shovel a lot of coal into it. And there's a lot of brute force on AI. And, sort of like running NCSA Mosaic back in the 90s, right? I mean, we didn't have any of this stuff. Like no one trusted anything. People were kind of like buying pizzas and stuff, but it took a while to sort of come up with the systems that end users, could really trust, have notification that think this was a trusted system. And I don't think we're there yet, but I agree that there needs to be, as people are now more educated about having sovereignty over their own data and being able to have that kind of, capability, frankly. And I think there's an opportunity there to as these systems come together, best practices, what have you, where people can have more control over their own data that they're creating and that they're using, and that their data is not just being fed into some other system to be trained and monetized. But Aydin, what's looking forward here, like in the future, kind of what are your thoughts about where we need to go with all this stuff to establish more edge AI trust?
I think the most important two things that I mentioned already is to create a well-vetted database of vulnerabilities, and to have an organization that tests for these vulnerabilities that is agnostic to a particular hardware or system. So if we can establish those two things, then I think, of course, the third pillar of this is to have some demand for it. If it is just a few security researchers or security practitioners who are doing it, then probably companies are gonna, they find out. So companies' priorities are to get the products into the market as fast and as cheap as possible.
Right.
So without having public need demand and some governance or some regulations that follow this, it's going to be very hard to establish. It's going to be easy to establish, but it's going to be hard to enforce this and deploy this in real world systems. So those three things are I think, critical.
Yeah. Well, I think there's going to be either Fortune 500 will determine that they will not buy and deploy systems unless they have some sort of security certification, which I think will happen eventually, and or someone like the EU will regulate, just like Cybersecurity Act, that all systems must pass some sort of level of security certification. And if some big organization does that, then it just happens worldwide. So I think we're kind of on that road. Ro, do you have any kind of closing thoughts? And I would ask Aydin too, like, where can people go to learn more about this topic, to kind of get more educated? I think at the end of the day, individuals becoming empowered with knowledge on this is a very powerful thing. So what do you suggest?
I think there are excellent pointers in the published literature, and I'm not talking about the published literature like academic papers like Aydin and I consume. There is a beautiful book by Michael Kanan. It's called T-AI, which I highly recommend to get basically the head around of the revolution of AI. Human plus machine from two business people, I mean, at the time, at least they were at Amazon, which is an incredible source. Super agencies, that was published recently by a prominent Greylock partners about AI and its percolation, and Read the Write On, which is about the Web3 revolution, which I'm really fond about it, because on the one hand there is this layer of homogenization and ownership back to the owners of the data, but it also, to scale that infrastructure, it required the internet to change fundamentally. So it will sprout a whole lot of innovation. So, but it will happen little by little, and AI will only benefit of it. So I think reading this helps people wrapping their head around these problems and the future.
Sounds good. And Aydin, other than kind of getting your PhD with you, what can people do to, that sounds like a long process, but, what do you suggest for people to get enlightened on this topic?
Yeah, so I guess it depends on who the target audience is. I usually ask my students to go read the latest and greatest papers published in a few select conferences in my area. That's where we get most of our source from. But I think, frankly, so I agree with what Ro mentioned, but I'll maybe highlight one other need here. So learning about the hardware side of things and how edge AI become risky, there is actually not a fully covered book on this topic, so someone needs to write it. Maybe it will be Astro, huh?
There you go. I think
Why
we're
not?
starting a project here. Great. Well, thanks again for both of you. I think this is really a great discussion for people to kind of learn about the topic. There's obviously a lot of work to do here and a lot of work that's been done, but certainly we'll get there at some point. But appreciate your time. Thank you both.
Thanks, Pete. Thanks, Aydin.
Likewise, for having us.